Pleasure. Thank you for having me. And like you said, Swapnesh, thanks to everybody for joining. I know it's a Friday morning, evening, night. So I promise, Swapnesh, I'll try to keep this as light as possible and as engaging. So Swapnesh, if I get into dark territory, feel free to nudge me and bring me back, so I don't get into a lot of detail. So Maya Systems is a conversational startup company. I mean, it's one of the fastest growing in San Francisco. We cater to the recruitment industry, particularly. I work as a senior product manager or senior technical program manager, which is the more relevant title. My job is to work with our tech teams as well as our client. So I have exposure to both.
Yes, Aditya, please. Go on.
Yeah, I guess that's it. I'll keep it short and sweet. We can get right into it if you give me the go.
Yep. So just before we go into the topic, a couple of things about Aditya is pretty interesting. Is one, his folks have joined in from India as well, which is very good. So welcome them as well. The other thing is the fact that Aditya is quite talented in the area of drama and music as well. So he's got his own band and he does stage shows as well. So Aditya, that's a very interesting thing about you, and I suppose you will add a little bit of drama to the kind of show that we have here as well. Now,
I will try my best.
before I go into giving you the complete control of this, let me just set the context in terms of what it actually means. The topic here that we have is a twist with artificial intelligence. The word twist actually means agreement. So the topic actually means an agreement with artificial intelligence because it's having so much of an impact in our lives today. In fact, in controlling some parts of it, I think we probably need an agreement with AI at some point of time, some level, right? So that's the logic behind this whole topic. And also today, Aditya would be focusing on the higher level of AI and the business application. So we would limit the scope of this particular talk to the area of application of AI in the business context. Over to you, Adi.
Thank you. Right, as I said, I make no promises, but I'll try my best to keep it as engaging as possible. So I hope you can all see my screen. So I've got two screens. So I might tilt. It's not like I'm not paying any attention. I'm just looking at the deck. So I want to start off with this amazing scene from Stanley Kubrick's 2001 Space Odyssey. Now, this is, I love this film to begin with, and it's Stanley Kubrick's sort of magnum opus. Now, the reason I like the scene is because what you see in front of you is an AI companion. Okay, it's called HAL 9000. So HAL 9000 is basically denying a request from an astronaut who's on board. So Dave was the astronaut, basically asked Hal to do something, and Hal says, "I'm sorry, Dave. I'm afraid I can't do that." And this is interesting because of two reasons. First reason is Hal is aware that if Hal follows that instruction, Hal's existence is sort of at risk. Now, if you think about that, right, sort of the concept of self-preservation, I feel that's an amazing concept that has driven humans to where we are. So you think about where we started off. We built tools from the stone to defend ourselves from animals, from other human beings. Then we got onto clothes, fur, and so forth. So the concept of self-preservation and existence pretty much drove us to where we are. There was, you think about it, there was incentive to do something, and machines don't have that incentive at least until now. And I'll get to that point shortly. Second aspect, I think, is the fact that this is based on a book written in 1968, sorry, 1968, apologies. 1968, Arthur C. Clarke wrote this. And his expectation was in 2001, we would have a system that does exactly what Hal is doing. So the point I'm trying to make here is while AI as a concept has sort of lasted for a very long time, I'll give you a few examples. You could argue we are not close. So on that note, this next slide, which I hopefully you can see on your screen. This next slide not only demonstrates my poor collage skills, but it also gives you hopefully an idea of the extent of AI in fiction, in games, in popular artifacts, right? So all of us have had some sort of exposure to AI, and believe it or not, whether you're a science buff or not, I am. Um, you somehow understand the concept of AI, but it's hard to put it in words. Uh, and this is something that a lot of researchers struggled with as well. To define intelligence is one thing, but to define artificial intelligence is on another level. And I'll sort of explain why I think that's difficult. In 1942, I think again it's another example. In 1942, Isaac Asimov, who was one of the fathers of science fiction, he wrote the laws of robotics, right? So this is as far back, and those laws are still, gold standard for robotics. Nothing much has changed. So the principle of AI has stayed pretty much the same until now. It's just that we've not got where we are. Now, the back in the day, science fiction writers, academics thought we would have our own companions that are AI driven, and possibly AI would rule the world, which hasn't happened. Good news, I guess. um, so the I mean, the good news, the bad news, the way you look at it, is we're not close. We're not close to building truly self-aware systems. And I think I came across this really famous saying. This was I was not able to get who said this, but it says for all the hubris of human intelligence, right? Humans have not been able to build a system that's close in terms of intelligence to him or her. And that says a lot because that's a paradoxical statement, right? We consider ourselves to be very intelligent beings, but we've never been able to build anything remotely close to our intelligence. Having said that, there's a lot we've done in terms of processing. And then I hope to explain that over the next few slides and you understand a few examples along the way.
So, so Aditya, I got two inferences here. One is that you have a lot of passion for science fiction movies, and I can see that on your slide. And I probably think these are your favorite ones as well. The second thing is the actual understanding of AI. What does AI actually mean? Because we have people from the age of 15 in the US who have startups like Tonmoy Bakshi to Andrew NG who have given us different definitions.
Yeah.
So would you be able to give us what definition works for you, and we can probably get a better idea of what AI is?
Sure. I think, it is sort of dangerous territory getting into the definition of AI. Trust me, this is, I know this looks like a mouthful, but it's one of the least complicated definitions that I could come across. Um, the key element here, I think, to keep in mind is the aspect of continuous learning, right? I also thought this is a great slide, to compensate for my rather attractive previous slide because it's a cliched question. And thank you for bringing it up. Um, the the idea of continuous learning, that's what is another aspect that's driven us human beings to where we are. We from the time we are born, we're taught to crawl, we walk, we cycle, we dance, we sing, and it's continuous learning, and that's what drives us, right? That's what drives us to who we are, and we're always learning. Now, previous systems didn't really do this. Previous systems were very, if I can say, linear based. They were very rules based. So, if you think about a simple if statement, if this, then do this, if not, do that. They were very linear. But the point where systems are right now is actually they are in a state of continuous learning. They are getting better. We are the crux of seeing machines perform amazing things, and I'm sure we will. Uh, so let me go to an easier definition, right? I think this definition is probably a bit of an overkill for the audience. So I like this definition because I mean it's simplistic to begin with. It's the fact that machines acting in ways that seem intelligent. Now, I mean, you might ask me what is intelligence, and like I said, intelligence
Uh,
means a lot of
I have
things.
to interrupt you there, Aditya. I have to interrupt you there, Aditya, because without understanding what intelligence is, AI would be very difficult for us to understand, right? So I've got a quotes and some, options for you to choose what intelligence actually is, and you tell me
Okay,
which one's the closest that you would call intelligence to be, right? So the first one
hey,
is
this wasn't part of our script. Oh my God.
it's something that you have to make it right. You'll have to choose the one that's closest, of course.
All
So
right.
the four options we have, the first one is intelligence is the ability to kind of study and reproduce in exams and to get good marks, which is basically, I think, what a lot of us have been exposed in school and college, right? So the ability to get good grades. The
Yeah.
second one is successful at work. Take this information and convert them into something useful and be successful at work. That's option two. Option three is to be able to think about an idea which is creative and then come up with the practical implementation of that. So basically something like a startup or a company or a business and so on. And the last one's a very interesting one. It's the ability to understand your spouse well.
Whoa. Yeah, that's. I think my wife's on the call as well. And my mom. This is a tricky situation. Um, So I think you raise it. I mean, all the options. Again, I'm not trying to uh, not dodge the bullet, but all options to me seem like a form of intelligence. Um, Intelligence is a bucket term. A lot of researchers call intelligence as a bucket term. It means lot of things. So my mom would say I was, probably doesn't think I'm very intelligent because I didn't perform very well in school, but my wife would probably say I'm very intelligent because I take good care of her. So it could mean different things to
One
different
way of looking at it.
people. But I guess the point I'd like to raise here, and since you brought intelligence, is in the diagram you see here is from the Turing test. This is from Alan Turing's 1950 seminal paper. It changed the way of thinking about system intelligence. Right? So it's very simple. It's a very simple concept, and I'm sure a lot of people know this already. But if you don't, in summary, it's essentially in 5 minutes, a human being, and I will try to use my laser pointer here, which doesn't seem to appear, but yeah. In summary, if a human being in 5 minutes is not able to identify if he or she is interacting with a machine or another human being, then we consider that machine to have passed the Turing test, right? So
Right.
look at the way he's sort of formulated this. He's not calling it intelligence because he knows intelligence is very difficult to define. So he called it. He said this meant passing the Turing test. That makes sense?
Yeah. So Turing test is a very important term for us in AI. So that wouldn't that be?
Yes, it is. And to be honest, a lot of machines right now will pass the Turing test. They may pass the Turing test quite easily. Um, I was
Right.
just thinking about this
Any
example.
interesting example? Any interesting examples of that, Aditya?
Yeah, this is a bit of dangerous territory. So the bot that I work on, so the conversational AI, it's a very polite bot, and she's called Maya, or it is called Maya. So we try to be general neutral. So it's very human-like, and a lot of users, mistake Maya for a human being. So they're conversing with Maya either over the web or over SMS. And I've come across several occasions where it's actually start flirting with Maya, and it's shocking because they start asking Maya what she's doing over the weekend and what she's
How
trying to
you
do.
feel it? How you feel it?
Yeah, it's a bit creepy, but the point here is um, Maya would pass the Turing test in that case because someone's convinced they're talking to a human being. Um, Having
Right.
said that, there's new regulation that's coming into being where bots are supposed to be very explicit. AI bots are supposed to be very explicit about the fact that they are driven by AI, and so that users don't get fooled into. And again, it's region-specific policies, but that's an interesting development.
All right.
So I guess in summary, I'd like to talk about since we spoke about AI as such, is to talk about AI subtypes. So AI subtypes, I know a lot of you know what, or at least heard of machine learning. Um, it's being shoved down our throats. I mean, I've read about a smart toilet that's based on machine learning right now. Basically, it measures
Wow.
your pressure, your heat in your body, and also studies your output. Right? It knows your output and figures out if you're doing well. So literally, machine learning is shoved down our throats. Um, I guess NLP is probably not so well known. Um, NLP is a very powerful toolkit. It's very powerful. It drives a lot of our consumer interaction with AI. And I'll try to touch upon what NLP shortly. And last is obviously robotics. Now, robotics, we've all come across self-driving cars and warehouse robots that deliver things, and trucks, automated trucks, which is a big thing right now in the mining industry. But I'm not going to talk about robotics because I don't think we'll have time. We can probably discuss this at some point later. But I'd like to talk about machine learning and NLP. So I'm going to call it NLP going forward.
So Aditya, it was very interesting because my next question was, are there any types of AI? And that was the next thing that you actually addressed. But from my knowledge, I thought AI was just machine learning. I thought it was just the same. I thought AI and machine learning. I see a lot of courses conducted by a lot of universities and stuff, and I see that the main agenda there is machine learning. So it's interesting to note that there are other aspects as well.
Yeah, fair point. The bread and butter of it is machine learning. So machine learning is more of brute force. NLP is a more nuanced a way of handling certain use cases. So if you think about it, NLP sits over machine learning. So machine learning drives the brute force, and NLP is the sort of nuanced way of looking at what needs to be done. And I'll show you a few examples that will hopefully explain this a little better.
So just for the benefit of the audience, the NLP that we have is not the neuro linguistic idea that we're talking about. So this is more to do with language, and language is one of the things that is so close to human beings, right? So I think you'll talk about that in the next part. Is that right?
Yes, I will. I hope I'm not going too fast. I'm aware we have a limited time, which is why I'm trying to just go a little. I don't want to stay on a particular slide. But let me know if you have any questions. I'm happy to stay and discuss. So here's a quick, homework for all of you on the call, and particularly you, Swapnesh. This is basically what machine learning is. If I ask you to solve this equation, and if you understand this, you understand machine learning, right? You solve this equation for n, which is 10 items. Let's say n is 10 items, and m is equal to 3. It's a very simplistic equation. As you can see, it's not that complicated. That should give you, it's like a revelation. You should understand what machine learning means. You want to give it a shot?
So you want me to try solving this equation that you have on the board, right?
That is correct.
And how much time do I have? Do I have a minute to do that?
Yeah, I think a minute should do. All right, I'm joking. I'm joking. This has nothing to do with. This has nothing to do.
What is that beta? What is this? What is that symbol? Beta. I know there's something called beta, but what is that?
So right, this is an equation from a clustering algorithm, right? That's beta. It's called beta caret or beta hat. This is a small element. Don't worry about it. I'm just kidding. This is just a joke. It's
all right. You were joking. You were actually testing my mathematical capabilities on a live show.
Yeah. If we get into a little more detail, I will reveal a bit, my mathematical capabilities as well. So we'll stop right there. Let's move on to what machine learning is from again a very simplistic standpoint, right? So In principle, machine learning is learning from experience. And the experience in this case is patterns in data. Over the last few years, we built troves of data, and machines have the processing power to look at hidden patterns, whether it's clustered or unclustered data, data that's grouped or not grouped. And that's sometimes referred to as big data. A good example of machine learning is Facebook. So Facebook, the algorithm, for those of us familiar with tagging photos, Facebook asks you to tag yourself, your friends, over and over again. But what you actually did is teach Facebook who you are and how you looked. And that came over a period of and now Facebook can do the tagging automatically because it has so much of information. It knows how Swapnesh Sebastian looks, how Aditya looks, and how my bald head looks. And it puts that into perspective. So that's a really good example of machine learning and its prowess. Some of the examples being Netflix recommendation, as well as Amazon recommendation, product recommendation. I'll touch on a few examples later in the due course of this presentation. So, machine learning is essentially made of sort of two primary use cases. It is sensing and prediction. Okay, so in terms of sensing, it's basically teaching machines to perceive and recognize data in this world. I'd like to go to this example of the children's book. Now, I think it's a fantastic example because, as a kid, most of us were given a book and were taught to identify different animals, label, okay, this is a cow, this is a dog, different shapes, different colors, right? But what you were actually doing was training the kid to recognize and label. So, and human beings are quite fantastic with working with brief examples. So you show a kid perhaps, 5 pictures of an elephant, and you perhaps, as a parent, you show the kid that the elephant has a trunk and makes a particular noise. The kid can build world context, and that world context allows the kid, in terms of its perception, it knows, you show the sixth picture, the kid will, in most cases, identify an elephant from, say, a duck. And I think that's the piece that really gets me excited because that's what we're doing with machine learning, and I'll show you exactly what I mean. Looks like
Yeah, just before we go on, yeah, the question that I have is when it comes to humans along with pictorial representations, I think a lot of emotions is also attached to these pictures. Like you take a child to a zoo, and the zoo has a lot of these animals, and the child is able to connect the picture with the joy of seeing the animals. So they tend to recollect stuff, and we tend to recollect a lot of stuff based on our emotions, our emotional connections with that picture. So do machines also do the same?
So I was going to get to that point. I think that's coming back to my incentive, right? I think fear is an amazing, it's an amazing parameter that teaches us a lot of things. Like for example, I'm afraid of cockroaches that fly. I will, I will run because I hate cockroaches that fly. But that as a kid, and that taught me a lot about flying, about a cockroach, and I understand concepts. But a machine, there's no incentive, right? But we are getting there where sort of get to that gamification zone. I'll get to that. But in most cases, machine see no incentive. You need to give incentive or incentivize the learning process in order for human or a machine to get better at recognizing and sensing things. So maybe I'll show you the next slide.
Right.
Uh, I think this is a fantastic short presentation in that Facebook. It's on Facebook that I found online, and I've read about this previously. To give you some context, so going back to the example of identifying animals or say a van, to a machine, a picture of a dog is basically a bunch of pixels, colors, shapes, and brightness, and that's captured classify the machine as numbers. The machine doesn't understand anything else. The machine doesn't get the concept of, 2 eyes, a leg, a tail, ears, none of that. All it understands is rudimentary information, which is numbers. And the same goes with, say, a picture of a van, right? So the machine will say this is just a bunch of numbers. Now, it's difficult for a machine to then, say, oh, this is how a dog looks, just based on the image. Now, with machine learning algorithms, what's happened is we've specialized the art of providing millions of examples of a particular image or a particular, I don't know, an entity to the machine, and then classifying that or labeling that. So, for example, in the case of a dog, you provide the machine with millions of examples of dogs, of various dogs, and you label it. You tell the machine, you categorize that this is a dog. And over a period of time, what the machine does, it sees patterns in numbers. And that's exactly how Facebook algorithm works. It looks at the pattern. I mean, it's a very simplistic way of putting this together, but at least at a high level, the machine is at a point where it starts identifying dogs or a van, a car. This is also being used by Google search, image search, and Google Lens. Google Lens is fascinating. I mean, it looks like magic. I remember when it first came out, everybody was blown away. But what we've done is every time we pass information to a Google Lens, there's somebody who's doing verification behind the scenes. Sometimes a human operator who classifies it as, yeah, this is this has been done properly or it's not. This is done in error, and the machine learns from that. Does that sort of explain the concept of sensing? At least at a high
Very
level.
interesting. That's very interesting because on a personal note, I just want to quote something from my personal life where when my daughter was real young, we started identifying dogs. She was able to see dogs, and she would call it a dog. She was also scared of the dog as well. So I think she was able to scan a few pictures and connect some of the emotions down the picture and identify it was a dog. And then when she was about a year and 3 months old, we took her to one of the zoos which had a show on dinosaurs. And when
Right.
we took her into that show, the moment she saw the dinosaur, she got scared and she said, "That's a big dog." And then very soon, within a few months, she realized that's not a dog. So I'm tying the concept of continuous learning to the pictures, to the amount of data that's going into these systems that we have today. It makes a lot of sense when you're connecting all these things.
Precisely. I think it's a great example. I think the, hunger, uh, fear of being beaten up by my mom, for example, because I've not done something right, when it comes to studying. So it's an incentive for me to learn and get things right. I think that's an amazing human quality. And machines, we are trying to incentivize. There's been a bit of development in gamification of algorithms and giving a reward to a machine. It's interesting. I mean, I'm not going to get into that territory right now, but it's as a concept. It's
I just
fascinating.
want to also ask another question, Aditya, if I may.
Sure.
Uh, can we use pictures of the past to generate something for the future? Like, can you generate the pictures of a particular object or a particular pattern or a concept, and then use that? Can machines actually use that to generate or predict something for the future? Is that possible?
Yeah, I think that falls right into the sort of prediction territory. It's a combination of sensing and prediction. Um, so, which is what I said initially. So, it's two primary use cases. There's sensing and there's prediction. Prediction is very powerful for industry, right? All of us would love to have a crystal ball and see where our future goes, but this prediction is based on hidden patterns in data. I know a lot of trading right now is done based on machine learning. So this is all automated right now. We don't have stockbrokers sitting there and plugging and buying. It's done through algorithms. A lot of algorithms right now buy and sell based on patterns, based on news, based on oil price, for example. Another amazing use case is credit worthiness. Right, it's a very important concept. for handing out loans or any sort of credit. So that's been handled by prediction. I think another amazing example. I'll probably get into that since we're talking about examples. So this is a high level example of a recommendation system. Okay, so let's assume Swapnesh, you like these certain films in Netflix. You like science fiction. You like superhero movies. So Netflix actually wants you to click the like or dislike button, and I'll tell you why. Let's say you watch Twilight or Sharknado. Hopefully not, because appalling movies. But nevertheless, um, if you were to watch and say I dislike this, what happens is behind the scenes, Netflix starts clustering you with the data that has collected over the years. So you fall into a bucket of users, of likes and preferences. And I've been told there's only about 8 9 user types in entirety. But there's small nuances
Wow.
to each of these types, right? There's small nuances, and I'll explain why. And then based on this pattern, what Netflix does is predict what you want to watch next. And that's exactly what's been driving Netflix's growth. If you think about it, what Netflix wants to do is to focus on this area of the recommendation engine. So, it doesn't care too much about this. So the most relevant content is displayed right next to in the area that I've highlighted right now. And as Reed Hastings said, and I think this is an amazing quote from Reed Hastings, who's the CEO of Netflix. He said, the biggest competition for Netflix is sleep. Right? He doesn't want Swapnesh to sleep. He doesn't want Adithya to sleep. He wants you to watch more of Netflix. And the way he does that is by showing you the most relevant content, keeping you engaged. Make sense?
Wow. Wow. And can we use the same idea, or can AI supporting machines or robots use the same idea for predictions in other areas as well, similar to this, similar to the ones that
Um,
we see on Netflix?
I mean, if you're referring to other layers, I'll stick to this example. I mean, let's think about an example where your wife has a Netflix profile. You have a Netflix profile. In addition to you guys seeing different content, because assuming you both don't share the same preferences, you will see different content. But let's assume you have the same preferences, right? Netflix has another layer of recommendation. So that layer is around the thumbnails, the picture that you see here. So I don't know, as an assumption, Swapnesh loves shows that have a lot of guns, bullets in it, right? So and versus your wife doesn't like guns. She abhors violence, for example. Uh, she'd probably not see the same thumbnail as you do. You'd see a thumbnail, you might see a thumbnail that has a gun, massive gun in the Narcos style that has bullets. So it's sort of two levels of getting you to engage with that content, right? It's trying to suck you in. It's not only the actual content, but it's the thumbnails. And it's actually yeah, I mean, it is dangerous territory because I've been told there's a bit of segregation going on based on race and ethnicity. That's a dangerous topic, so I'm not going to talk about it right now. We'll save that for later. But that's in principle the recommendation systems. I'm aware we are short on time, so I'm just going to switch to the next slide. If that's all right. Unless you have any questions. Okay.
No, they're good to go. Yep.
Cool. So the next important concept in machine learning is NLP. Okay. Now, all of us can agree, hands down, language is something that's really difficult, or has been difficult, and it's a systematic approach to learning. So we first been taught, alphabets, then we move on to small words, then we move on to bigger words, then we move on to small sentences, then we move on to big sentences, and then we move on to paragraphs. And on top of that, there's another level of sort of abstraction, which is we use alphabets in mathematics, right? And that's
Yep.
it's come over a period of time, right? It's taught us. We've learned that okay, this is the model of the world. This is where it comes to play. Now, for machines, it's quite different. Machines don't understand this because at the end of the day, back like I like this cartoon. A lot of people use this for AI and machine learning, basically, or NLP to be precise. Is to a machine, it's almost like the cat. The cat doesn't really understand what's going on. The cat's just looking at this lady. It's like okay. Whereas maybe lower level languages, the dog sort of understands a little more context. And I mean lower level, I don't mean system level. I mean maybe 2 levels above. So the dog understands just maybe the name. It understands a bit of context. Oh, so Ginger is my name, and you're calling me out, right?
Yeah.
So let me give you an example of. I think this is a fantastic example of the complexity of language. So this is a famous advert from Boeing. So McDonnell Douglas was basically merged and they formed Boeing. So this is a statement that says, "At last, a computer that understands you like your mother." Now, if you look at this for a few seconds, you understand there's a couple of meanings here. Okay,
Yeah.
the computer understands, you as well as your mother, or does the computer understand that you like your mother, right? So for a human being, we've already hit an issue. So you can imagine for a computer or for an algorithm, for a system, how difficult it is to process natural language. And I mean, I'd like to get into a little more detail about how there's syntax-based programming, branching and trees and forest trees, but we don't have time. So I think what I'd like to do is to talk about the applications, which I think will be a little more exciting for all of us. So like I said, NLP is something that we use on a daily basis. Google search is basically, apart from the search engine, runs on NLP. It understands the text, it understands your intent. So if you ask a
Right.
question as Swapnesh, it understands your intent. What is Swapnesh interested in? Why will Swapnesh ask that question? Why does Aditya ask the questions he does? Same with Google Translate. It's just brute force machine learning and NLP sort of playing in tandem. Extraction, generation, all sort of different forms of presenting text. And I'd like to bring an example of Maya here. Like I said, Maya does a fantastic job at understanding sentiments. All of us humans want to feel we are understood. So this is a screenshot of the conversation Maya has. You see here, the user basically says, "Hey Maya, thank you so much for your help," right? And that's obviously the person feels it. I mean, I don't know if they really feel it, but at least in the message, that's what it conveys. Uh, the Maya recognizes that sentiments, right? Maya says, "Oh, my pleasure," right? I'm glad you're happy, and then moves on to the question. Now, this is a fantastic, engaging experience for a user. Now, imagine if it didn't say anything and just said, I have a few questions that fit your profile." That's just, you don't feel like it's a natural conversation. So I thought this was a really good example to highlight about sentiment and intent analysis. I mean, another few examples, of course, is Amazon Alexa, Google Home. So these are all voice-based systems. And the interesting thing about voice-based systems is a lot of the hardware units are sold at much lesser cost than their manufacturing costs. And the reason for that is these companies want people to talk to their machines so that they have real world examples, so that they know how Swapnesh will talk, so that they know how Aditya will talk, right? And they can use that real world examples to make their algorithms much stronger. And I'm sure there are, at the risk of sounding negative, there are sort of negative, devious ideas behind this, to do more relevant advertising. There are a couple of times where I've spoken to my wife about something, I don't know if Google search, Google Home has heard it. And I log on to my system and I see the same thing as an ad. And I'm thinking to myself, hey, hang on, how did that happen? Are you listening to everything? But I'm not going to be a skeptic. I'm not going to be a skeptic at this point. I will trust that Google only listens to us when they're supposed to. But anyway, the point here is, you know, that's the sort of the next driving force of NLP. The last bit I think which is very interesting, not a lot of people understand, is targeted advertising. A lot of the ads that we see, is actually based on a combination of intent, NLP, and machine learning. So that you see more relevant ads. So I know Swapnesh, if you are perhaps interested in sports, and you search several times on things on sports and training, you probably see ads that are more relevant, and that's NLP. That's using intent, using extraction, right? That's a really, really powerful tool that's actually driven a lot of the advertising online.
And I think this is so very interesting because I think it ties up to our title as well, a twist with artificial intelligence. Because from what you're saying, it looks like the Google Assistant probably knows us better than some of our own kith and kin, right? So might be overhearing a lot of our conversations and overseeing a lot of our browsing history. So they might be, it might actually know better than some of my own folks.
Yeah, I mean, like I said, by law, they're only supposed to activate when there's the keyword, but, who knows, right? I mean, I have conversations with my Google Home once in a while. I try to have a bit of banter just for fun, but it's amazing. It's an amazing experience. I'd like to move on to some very innovative uses of AI in the industry. I have three examples. I hope you find them as interesting as I do. So the first one is data storytelling. So this is a company called Narrative Science, and it created a big furore when it came into being. Because what it does is you provide this algorithm or a product, some data set, a massive data set, right? So, for example, this is shipments, and what this algorithm does is it converts this data into text, semantics. It builds a narration. So you can see here, this is what's been generated by, right? It generates all the text based on just that data. So you don't need to have people come and talk about it, right? This data is just presented. And funnily enough, a lot of this has already been done by Forbes and Reuters. So a lot of the data that you see for commodities, financial reports, they're actually being produced by these bots. People don't sit. So it's almost like it's a AI reporter. So reporting has been taken over by AI. AI can see patterns. They can talk about, where they think improvements should be made. It's fantastic, this product. Um, the
Let me just pause here to ask a very important question, which I actually had even before we came into this, and a lot of them are actually asking it to one of our members at Phase 5.
Okay.
Is AI going to kill jobs? From what you're saying here, it looks like a lot of the data operators and a lot of people that were actually doing this work manually would probably have to move to another type of job or probably move to the design of this kind of software or AI systems. Very controversial question, but
yeah, it is a polarizing question, and as someone who makes a living off AI, I'm not being biased when I say this. I feel like technology always disrupts, right? Technology has always brought disruption to industries, to our lives, and for good reason. Take for example, when we used to farm by hand, when we moved to bullock carts, that of plows that did farming, that was one level. It reduced manual labor. Then we moved to say assembly lines, that reduced manual labor. When the radio, when the TV came into being, I think the TV was invented about 1930s, but it became commercial about 1960s. Um, the radio was everybody said the radio is dead, and there's a song that says the radio, the video killed the radio star. People thought the radio is dead. That's it, no more radio. But look at where we are. We're about 40 years from then, and we still have radio. We've got a different form of radio. Radio has evolved. And the fact that a lot of the innovation has taken away manual repetitive labor, right? The manual repetitive piece. Because if you think about us, we human beings can work with small, small data. We can work with small data. When the data becomes massive, we need systems. Systems do it better, right? So it's almost like we
Yeah.
work in tandem. We should work in tandem. Human beings, in my opinion, can focus on the more creative aspects, on our core competencies. Like we wouldn't have AI if we were still farming. Think about it. We wouldn't have that. We'd still be farming. And not to say farming is a bad thing, but it's created opportunities. Is what I'm trying to get to.
Right.
Uh, if that answers your question, I'll just probably move to the next slide. Is it all right?
Yep.
I hope I hope that answers your question. I think this is a really good example of AI in the medical field. So this is a product called DCT. Um, so, so there's a test that patients who have cognitive impairments have to sort of undergo. The test is basically they're asked to draw a clock and mark out 11:10 or a certain time, and there's a human reviewer that sits and observes this candidate or the patient, and observes how they do it. And they have a bit of metrics to see, okay, how long does it take? Is it symmetrical? Did the person's hand shake and so forth? And this is one of the tests that have been carried out for quite some time now. Now, this has actually been sort of handed over or can be handled by machine learning. The way you would do it is, I believe you have a digital pen, you have a bit of cameras, a tablet, and the patient draws the same thing, but you have machine learning algorithms that do the analysis on the back end, right? And
Right.
the beauty about this is with machines, are consistent. They are accurate, always more than human beings, because they know what they're meant to do, and the error margin is quite less. Because human beings, we might have our own problems in our life, and we think about other things, and we might have error margins. The error margin for machines are quite less, as we all know. So this is actually detected cognitive impairment before it actually manifested. So people who had absolutely no signs, who gone and sat, when they had small traces, the machine had detected it. So they could be treated well in advance, well before this sort of blows up, or the ailment blows up. So I thought this was a great example as well. And I guess the final example, which is something that is close to my heart, is again back to films, is script analysis and validation. Now, the reason I find this fantastic is filmmaking is one of the most riskiest business, right? There's no, it's not like you can do a focus group study and say, how's this film going to perform? There's a lot of risk. There's a lot of money being invested. There's a lot of people. So it's a risky business. It's a high reward, high risk business. There's this product called script book, and there are several products where you can pass the script along with certain parameters of the script. So you can talk about the genre of the script, the star cast, the actor, the actress, the time of launch, the director, the music director, and so many parameters. And what this product does is it compares and studies patterns, and it'll give you the answer of whether this needs to be greenlit or not, so whether this film needs to be produced or not. I mean, think about it, right? This is something that's been done by a machine. I mean, there are some people who can do this. They can see there are these wizards who can study a script and say, yeah, that's a success. I'll give you an example. Get Out, which is Jordan Peele's hit film. A lot of people had a bit of apprehensions about making it. They're like, this will this work? So they actually passed it to the script book. Script book studied the script for Get Out, and it said, yes, you can greenlight this. This will, but again, it's a machine. The box office revenue was much shorter than what they actually got. So it was an error, which meant that it showed lesser revenue. But one could argue that it will do better over a period of time, right? So it's only come to being right now.
And I think that'll be good business in India as well when it starts working. When there's a higher success rate, it probably will do or will be a good product in India because we make some good movies.
Exactly. I mean, I hope we tend to do this. I mean, you don't have to take it as, as the answer from, God or whatever. It's just it's giving you guidance, right? Think about it as guidance, and then you make a decision based on that. That's pretty much the way I would see it.
Also, another question here on this particular example that you gave me. If I apply this to other concepts, will we see bots coming in to be part of a board meeting so that they can actually do a lot of this data verification and probably give some legal advice and be a part of the board? So, considering that humans probably cannot process so much data, you could have somebody on the board who's actually, an AI system, which is doing a lot of validation and gives one of its opinions, and it's up to the board member to decide whether to go ahead or not
It's
go
a,
ahead,
it's a,
and probably in regulation as well. Sorry.
I mean, it's an interesting question. See, one of the things about machine learning, especially when you get into sort of blue ocean, right? So film, I would say, is blue ocean. You're getting into new places that we've not done or gone before. The problem with a lot of AI algorithms right now is AI cannot explain itself. It's very difficult to understand why the machine did what it did, and that's a bit of risk. And people are still trying to figure out how to solve that problem, because until we get to that point where machine can comfortably tell you that I did this, this is my result because of all of this. In some cases it is able to do that, but in sort of new spaces it's not got there yet. So again, it comes from a bit of being self-aware, right? You gotta, if I can use the term, be able to explain why you did something, why you gave that result, and that that's a big that's a big hurdle to jump.
Right. So, in the interest of time, let's quickly move on to the next one, Aditya. Wow,
Um,
you're
I
done.
mean, this is my last slide. So what I want to leave everybody with is not only an visual a still that traumatized me as a kid. I still have nightmares. But this is what people expected AI to do in 1998. People thought in 1998 we would have robots trying to conquer the world, right? As you can see, I sort of was of the opinion I would see a robot do this, but yeah, we're not going there yet, which is good news, I guess. Yeah, I mean, I think that's it for me. I'm open to questions. I know we only have 1 minute.
Right. So, one of the questions that has come up, Aditya, is this concept of AI has been around for a few years, from what you said. I think for close to 50, 60 years, and has been in movies for quite a while as well, right? Why AI so much now? Why is so much importance given to AI?
I guess that's it's a fair question. I've asked myself that question, done a lot of research about it. Um, I can give you my opinion. So my opinion on this, based on what I've read and researched, is it's sort of threefold, maybe. So the first is obviously computing power, right? We didn't have machines that could scale up. So cloud computing added a lot of sort of spearheaded this movement. We could now send our processing power or share the processing power across systems all over the world. So it was not focused to say, the deep blue or one supercomputer. No, not necessary. You could push your processing across several systems. So that's the scale of it really helps with processing big data sets. The second part I would say is more around the number of data points. There's so many areas where algorithms can capture data. Now you've got people walking with phones, tablets, computers, consoles, you name it. There's so many points of data capture from real users, right? And that's adding to all this big data and the data that's available. A great data scientist and a product manager would work together and try to formulate, the next big idea based on the data that's available there. So I think that's fascinating. The last point is again my opinion is globalization. I think that the sort of the access to research us to us moving from different parts of the world, to the fact that a lot of offshoring happened, and we've got companies in India, in China, where they've been introduced to AI, and now they start building amazing applications themselves. It's pushing this forward. So it's all sort of a, we make it more democratic. Everybody's part of this. It's not only to the elite, right? Everybody is part of the AI journey. That's actually
Right.
pushing this forward. But having said that, you know, given the situation right now, I don't know how the world is going to pan. Everybody's becoming more inward looking. So see how it goes.
Right. So in the interest of time, we have one question, and you have 30 seconds to answer that. It's actually come
Wow.
out in the chat, and the question is more related to AI with regard to healthcare. Are we going to get to a point very soon where we can actually predict a pandemic? And you have 30 seconds.
Uh, See, if we were at that, so I'll answer in two parts, right? If we were at that stage, we should have done this already. We haven't, right? The signals were clear. Everybody had data. We didn't. So that answers that question. Will we get to that point? I suppose so. Because pandemic research is basically what we use in AI as well. It's node branching. It goes back to what I said, forests and all of that. It comes to the same. It falls in sort of the same bucket. But here's the thing: it's down to politics. Right? If there were certain countries that know about an issue, and again, not naming names here, we could have solved this
We'll
problem.
we'll,
So
we'll have to leave that debate for another day.
I guess so.
Yes. Right. So Athithya, thank you so much for coming in and sharing your valuable thoughts. I think this is very educative, presentation for most of us here across India and across the globe who've joined in. So this gives us a perspective of what AI is and probably what it's going to be in the future as well. And thank you for making our intricate conversation simple.